Right, let me show you how to solve this logarithm problem. All right, so we're given that this is equal to this. As usual, we start with solution. To be able to solve this, you need to understand one of the rules of logarithm, and that is the power. So it says that if n log b base a is given to you, it is same thing as log b base a raised to power n. So that n which multiplies the log becomes the power. So these two are the same. Similarly, if you have log 10 base 3 raised to power 2 is same thing as you use the power to multiply the log. That becomes 2 log 10 base 3. No magic. One of the ways of understanding mathematics is being able to remember the theorems. So we're going to implement this here now, and you notice that it's not that difficult. So do the same thing here. This can then be written as log 4 base 10 raised to power y minus 1. I've done this here. Equal to, on this other side, we have log 16 base 10 raised to power y. So we've implemented the theorem here. Another one says that when you have log a, or if the bases are the same, then you can cancel out. So log base 10 can cancel out log base 10 because they have the same base. Therefore, we are left with what? 4 raised to power y minus 1 equal to 16 raised to power y. How else can we write 16 so that it will have the same base as this 4? If you are looking for 4 as the base, that means we are going to be dividing 16 by 4. If you divide 16 by 4, it will give us what? 4. To get back my 16, that means I have to say 16 equals to 4 times 4. And that means 4 times 4 is what? 16. That can be written as 4 raised to power 2. Do you understand that? There is no magic. So 4 times 4 is same thing as 4 raised to power 2, which is also equivalent to what? 16. Instead of writing this 16 here, we can then replace it with what? 4 raised to power 2. Of course, there is this y. So let us use a bracket to demarcate the 2. This further reduces to 4 raised to power y minus 1 equals to, multiply the powers. So we have 4, 2 times y, 2y. The bases are now equal, just like as we did here when you cross out log base 10 and log base 10 here. You're going to cross out this 4 and this 4, and then equate the powers. So if you have cancelled out 4, we are left with y minus 1 equals to 2y. Now, collect like terms. That means let the numbers come together and the ones with alphabets come together. That same alphabet. So we've got y here, we've got 2y here, same alphabet, right? We're going to leave our minus 1 here because there is no other number that is similar or alike to it. So we're going to leave minus 1 equal to 2y. When this young man moves from here to this side, the sign that he has here is plus. Because it's changing position, it's going to be minus y. Now, this y has an invisible number. Whenever you see a number, a letter, for instance, y, there is always one that is attached to it. So it's an invisible number. That's why we don't write x as 1x. It doesn't make sense. But just know that every alphabet that is standing alone has an invisible 1 in front of it. If that is understood, then we can solve this problem. So we're going to say 2y minus 1y. That will give us minus 1 equals to y, or therefore y equals to minus 1. QED. Quiet, easily done. Please, if there's anything you don't understand, comment, and then remember to share, like, so that other persons who don't have the same opportunity as you will be able to stumble on the same problem and then understand how to deal with it when they come across a similar question. I'll see you next time. For now, take care and have a lovely day. Bye.